Hello, and welcome to the Shed Chat Lab. Today we're going to be looking at this field strength meter that I built, a visual indicator, as you can see there, as well as a squeaky detector, as they call it. So I'll just show you what that's all about. So I've got a short made-up antenna I just built out of an old whip as such, just connected to a BNC. Just going to prop this here. There's not much room, to be honest, to actually show you how this works and film at the same time. So first, switching over to the meter. Maybe you can see that on and using a 2781 walkie-talkie. I'm just going to press transmit and bring it near to the meter. You can see the meter going up there, showing the field strength. I mean, it's not relative, this meter, it's not accurate. It just gives you an indication that it is actually picking up an RF signal as such. Now switching over to the other side, we have got what you call a squeakie, which detects the RF field strength by sound. So if we set it just before the threshold, now I'm holding the walkie-talkie further away this time, and you can hear it's already picking it up. So that's about 3 feet away, and as you come nearer, it obviously gets louder. So 2 ways of receiving an RF signal as such. See if there's an RF signal present, either by sound or by the meter. So this is not going to give you an accurate reading as such on the meter of what the field strength is. It's just an indicator really, and as you drop the power on the transmitted signal or increase the power, you will see the meter increase as such, and also similar for the sound. If you increase the signal strength from say the walkie-talkie from low to high power. So I built this really to test any walkie-talkies, transceivers, that kind of thing. If I purchase one and it's for spares, etc. It's just a quick way to see if there is an actual transmitted signal, and you know then you're sort of halfway there. So it's just a quick test really for that kind of thing. So this is the box I made on the 3D printer. Not turned out that great, to be honest. Just trying a new update of the slicer, and I don't think the settings were quite right. The edges on 2 of the corners there, for some reason, didn't turn out that good. We can see the battery holder I've put in the bottom to hold the PP3, speaker grill, the 2 control pots, and the meter at the top, and the back just fits on, screws down. I don't know what I'm doing. And the on the top for the socket and the switch, antenna socket and switch. Yeah, and that's about it. It's a bit rough, like I say. Got to look into that. Did change it onto a new spool, so Could also be that, but I think it was the slicer, to be honest. But that's by the by, it will do the job. So instead of using the multimeter as in the original circuit, I'll just use this little DC LED meter as such. It's just got 3 wires on it. Yellow is the sense wire, which comes off your positive. Black, which is the ground, which is used for the meter, also the circuit as well in this case. And then the red's the positive to power the meter. If you're just using this as a plain DC voltmeter straight off a battery source, etc., then you'd connect the yellow and the red together to indicate what the voltage was. But the red and the black actually powers the meter circuit as such, instead of using a voltmeter that this was built into, multimeter I should say. This is the squeaky side of the meter. It's based on a 555 IC timer. A few components, little speaker, everything I'd got in, to be honest. All I had to buy really was that little meter. The potentiometer for sensitivity, I used a 50k and got a 25. If I do get one, I'll replace it and see if it makes any difference. Built the 2 circuits on a piece of Veriboard, strip board. Make it easier to, rather than going through the trouble of making a PCB as such. Just went ahead and made it on strip board, Veriboard. So here's the spaghetti junction, as I call it, inside. Bit of a mess, but wires could have been shorter, soldering could have been better. I just wanted to throw this together and see whether it worked, to be honest. There's the switch, which is switching positive on the top rail, negative in the middle, and the antenna on the bottom. There's the meter, little meter in there, board with a circuit on, and just a bit of Veriboard. You can see there they've got the potentiometers attached to, and then just flying wires off onto the other board. Little speaker, which does a job for this, and the 9-volt battery, which needs holding in with a bit of foam actually. Well, that will do the job. But yeah, that's how I've built it. Not very pretty inside, but it does the job. Just put the screws back in that. So as mentioned, I'll leave a link below to the original circuits, where I got those from. Take a look at their sites and it'll give you an idea. You could just build one or the other. Build the meter, just build the squeaky. I'm sure it'll come in useful, either or. Also, we'll endeavour to make another video when I've tried this out a bit more, perhaps change a couple of components, see if it's made a difference. But there it is, field strength indicator and field strength squeaky. So, thanks for watching. Please subscribe, like, leave comments, all the usual stuff. And we'll see you soon. Bye!